I
Okay.
can create a table
Or not.
or graph after an exponential.
I don't think you can actually read.
I can.
Is there
Okay, so the title of our page is exponential functions.
People just disrespect your thing so Look.
It's okay, when I take all the glue and stuff away and y'all just have to come up with a way to stick it to your paper yourself, y'all learn then.
Now it don't even come out.
Alright, so this says I could create a table and graph for an exponential function. Do not throw that.
Put that in the first drawer, please, sir.
Sir, you cut it.
Gosh, I need you to breathe over there. Also, don't forget to buy an Earth Day shirt. We have 9 so far. We need 20 for us to get 30 points in our 30% category.
Wait, so you don't get that?
Yes.
Oh, okay.
Okay, so if we sell less than 20, the 30 points go to a 10% category. If we sell 20, the 30 points go to a 30% category. And if we sell 30 or more, the 30 points go to a 60% category.
We still gotta beat that what's the name later.
Yes, but I think we're winning. Barely, but I think
Y'all
we're
have
winning.
money in that content? In that, business? Right.
That's
Yeah, you got money on it?
10.
$10.
Y'all bet $10 on who won?
Alright,
No, myself.
I think so. Yeah. We're barely beating her, but we're beating her.
We still have $6, so that's
Be quiet.
Alright, so Thursday and Friday we talked about exponential functions. Can one of you please tell me what an exponential function is? What is an exponential function? Think back to what we did Thursday and Friday. Does it have to multiply by 2? It doubles or triples, right? It's not constant. Okay, what else?
Oh, yeah.
Take a point, y'all. Good job.
It was a piece of hobbies.
This is the thing.
And it was linear and with.
Is an exponential function linear?
No.
No.
Linear was like a straight line. Exponential was the one that.
Curved.
Yeah.
Curved. Awesome. Both of you take a point for your team. So today we're going to define it, and then we're going to practice graphing, and it's fairly easy, and then we're moving on. So get excited. So the definition, or my definition, that we're going to write right here. An exponential function. Please put your phones up. Like, away. It's red day. I don't want them in your lap. I don't want them in your pocket. I don't want to see them. I don't want to see the dang flash. I will have a collection of cell phones for the rest of the day if I see anybody's cell phone again. Do we understand?
Oh,
An exponential function is a function with an exponent of x. Remember, on Friday we had 2 to the x, right? And on Thursday we also had 2 to the x when we were cutting. What are the 2 types of functions that we have? 2 types of exponential functions. One starts with a G, one starts with a D. If it goes up, what's it doing?
Increase.
So what's a word that starts with a G that's increasing? Growth. Fantastic. What would the other one be? Decreasing, which is also called the decay. So we have growth and decay. So our function is a times b to the x. This is always the starting value. So if we start at 1, what's our starting value? If we start at 75, what's our starting value? Fantastic. If this value, b, is greater than 1, it's a growth. If it is greater than 0, but less than 1, it's a decay.
Wait. So does it always have to be? Is it always gonna be 1, or is it just gonna be?
It can't be 1. Your b value is never going to be 1.
No, I'm talking about like that. It has to be greater than.
Yeah?
Oh, I thought it was gonna be like greater or less than the start.
Mm-mm. So it has to be greater than 1 or greater than 0 but less than 1. What numbers are greater than 0 but less than 1?
Wait.
1.
Fantastic. Take a
What
point
is
for
it?
your team.
You know.
So like 0.5, 1/2, 1/4, 1/3. Decimals and fractions are greater than 0 but less than 1. And that makes a decay. Alright. Are we ready for some examples?
Yeah.
Oh, sweet potatoes. Alright. I'm recording. An example could be g at x equals 16 to the x power. That is an exponential function because we have a base. This is our b. Our starting value would be 1 since we don't have a number out front. And x is our exponent. A graph of an exponential function. If you guys remember from Thursday and Friday. Looks like this. Now, is it ever going to hit 0? No. It's going to come real close, but it's never going to actually hit 0. So what would a non-example equation be? These are 2 examples. What would a non-example equation be? So if I said f at x equals, what would it have to equal for it to be a non-example, for it not to be? Use x. What would it have to look like for it to be a non-example? So what's an equation of a straight line? So give me an equation. Awesome, take a point. 2x plus 4. And what would a graph of a non-example be? A straight line. So like this. Those are non-examples. What kind of line is this? Other than a straight line?
Linear.
Linear. Fantastic. If you said linear, take a point.
What is a non-example?
Say it to me again.
If it's at 0, would it be a non-example?
What about is that an exponential function?
Yeah. No, I'm just kidding.
That is not an exponential function. That's a parabola. What kind of exponential function is this? Is this a growth or decay?
Growth.
What about this one?
Growth.
Growth, because it's greater than 1, right? Okay. Are we ready? Anybody?
Yes, we're ready.
Anybody? Alright, turn your paper over. This is going to be 42B. I've got the air on. Alright, so before we graph, we're going to create a table of each function. And our first exponential function that we are going to graph together is going to be f of x equals 3 to the x power. Now, do you think this is going to be a growth or decay?
Growth.
Why? Look at us go. It's like we're ninjas. Now, when you're creating a table, I want you to use the same 5 values every single time. I want you to use -2, -1, 0, 1, and 2. Every single time. And are we going to plug those in for x or for y? Look at us go. If you said x, give your team a point. If you said y, rethink what we're doing. Alright, so our first value is f at -2. So what are we going to plug in for x? Okay, we should be a little quicker on answering that other than the people who were whispering at me. And y'all know I can't hear whispers. Alright, what do we do with negative exponents? Flip it. Awesome. So it'd be 1 divided by 3 squared. And what's 3 squared? So it's 1/9. That's it. That's all you do. Yep, you do it over and over and over. So f at -1 equals 3 to the -1. What do we do with negative exponents? Flip it, and that's 1/3. It's magic. 0 is 1. Why is 0 1?
Because anything multiplied by 0 is 1.
Anything to the 0 power is 1. Both of you take a point. Good job. Alright, 0 is 1. Alright, what would f at 1 be? It'd be 3. Because it's 3 to the first power. And what would f squared be?
6.
What's 3 squared? But Curtis, you said it with confidence, baby. I'm proud of you. Alright, we created our table. Any questions on the table? What do we have to do after we create a table? Graph it. Now, do we have any negative numbers in our y values? No. So we're going to create a graph that looks like this. I'm sorry? I know. Alright, so let's plot our first coordinate. Our first coordinate is -2, 1/9. So you go left 2 and up a baby bit. Alright, -1 and 1/3. You go left 1, up a baby bit more. And then you plot 0, 1. You plot 1, 1, 2, 3. And you plot 2. Oh, Blair, you wrote 6 and you should have wrote 9. And you should say something. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, is this going to make a straight line? No, it's not. Guys, exponential is not linear. It does not make a straight line. So it looks like this, and it goes on forever. And don't touch the x-axis. It may look like it on the computer up on the screen up there, but it does not actually touch the x-axis. It is never going to hit 1. I'm sorry, 0.
Will you take points off?
Yes.
What about our little arrow?
I'm okay if the arrow touches. Just not the line. Alright, do you want to try one without me, or do you want to do one more together?
One without you.
Okay. Is this one going to be a growth or decay? Why? Look at us go.
Can you tell me if my card is
Sure.
That's right. Okay.
Okay. So you don't need me
I mean, I do need you.
to exist. All right. Did y'all use -2, -1, 0, 1, and 2?
Yes.
Okay. For -2, did you get 1/16?
Yes.
Look at us go. For -1, did we get 1/4?
Yes.
For 0, did you get 1? For 1, did you get 4? For 2, did you get 16? If everybody got the table correct, give your team a point. We can't go over today. Oh crap, you can't go over today.
Why did you say
Once,
Which one was it?
probably my favorite school?
I didn't look at you. My world does not revolve around you. I know you think it does, but it doesn't. Calm down. Alright, so for -2 and 1/16, you go left 2 up a baby bit. -1 and 1/4, you go left 1 up a baby bit more. 0, 1 is right here. 1, 1, 2, 3, 4. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Lots of points. So for the fractions, you just go up a little bit. Alright, so both of these were what kind of exponential function? A growth. So now we're going to graph a decay. Are we ready? Are we super excited? Can we get super excited? If I can get super excited sounding like this, y'all can get super excited not sounding like this. I am. Can't you tell? This is my happy face. Alright, so I'm on 42C. Alright. Now, how do we know that this is going to be a decay? Yes. So if you said that stuff, you get a point.
Oh, we get to go over today.
No, it's Tuesday.
Oh, no, that's Monday.
Yeah. Yeah, I'm okay if you go over today since it's a short week. You can go over today.
So we have like 3 points.
Yeah, we have.
What, we can't go over today?
You can. I'm fine.
I already got like 18 points.
You don't have any. You have only written down the first page. You get nothing.
No, I haven't.
You do not pass go. You do not collect $200. Alright, so we're going to use the same 5 points. -2, -1, 0, 1, and 2. Okay, so this time, for f at -2, we have 1/3 to the -2 power. Can we have a negative exponent?
No.
So we flip it, and it becomes 3 squared, which gives you 9. That's it. I know that's crazy magic, but you just flip it when you have a negative exponent and then square it. It is voodoo. Alright, so 1/3 to the -1, you would flip it and it would become 3. What is anything to the 0 power?
1.
What is 1/3 to the first power?
3.
No. 1/3. And that would be 1/9. That's it. So it's just the reverse of what we just did. See how this one was this way and this one was this way? This is getting bigger, so it's a growth. This is getting smaller, so it's a decay. Magic. I know. Teaching you all that Harry Potter witchcraft. Alright. Oh, I should have moved my y-axis over a little. That's okay. Alright, so let's plot -2, 9. You go left 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, left 1, up 1, 2, 3. 0, 1. 1 1/3. 2 1/9. Is it ever going to touch 0?
No.
No. Magic. And that's a decay. Yay. Can you graph one without me? Oh. Why did you not give me that? Humans. Alright, Odamas and then homework. Alright, so I want you to create the table and graph that one without me. Did y'all get that as your table? If everybody got that as your table, give your team a point.
I got the last one.
Alright, I'm not going up to 25, so, -1, 1, 2, 3, 4, 5. And if everybody graphed it right, give your team another point. Alright, homework. Bless you. Two problems. That's it. So we